Hi everybody, it's Sue McBride again, and we are going to be working on the PowerPoint for section 3.3, Graphics in the Media. Your learning goal here is to understand how to interpret the many types of more complex graphics that are commonly found in the news media. So to do that, we're going to be looking at some very complex graphical displays and doing a little bit of analysis on them. This is going to lead into section 3.4, which tells you some of the things to watch out for that can be misleading in the graphics. So 3.3 and 3.4 kind of go together. All right, so let's take a look at some of the graphics. We have this thing called a multiple bar graph. I'm sure you've seen these. And it's just a simple extension of a bar graph. Here it has two or more sets of bars that allow a comparison. So you'll always need to find the key in the graph so you know what's what. So in this case, we have allowance, handouts, and chores. We have three different things and we're comparing them for age groups. So whenever you're reading a chart, just like when you're making one, you need to put in your labels. When you're reading them, it's also critical to read the labels to see what the horizontal measures, what the vertical measures, and what the whole graph is about. So in this case, we're looking at median weekly income from parents by age. Not the age of the parents, the age of their children, I am assuming. All right, so then I can look at the key that says the allowance is in one color blue, handouts is in red, and chores is in a second color blue. And then at the bottom, I see my ages split out. So I only have three age groups I'm looking at. Ages 9 through 10, 11 through 12, and 13 to 14. But I have three within each, so hence it's my multiple bar graph. The side to the the vertical side isn't labeled, so we're just going to have to assume that's the money that they are getting for each of these things. So someone in the age group 9 to 10 gets, it looks like $3 for allowance, $7 for handouts, and $5 for chores. So if we do a quick addition, what's that? $10, $15 over the 3 for the age of 9 through 10. Then my 11 through 12-year-olds seem to get a whole lot more in handouts, a little bit more for allowance and chores. And by the time they get to 13 to 14, they've got, what is that, 27, 28, 29, 30, $32 in spending money. So we have to read everything very carefully to see what is involved. All right, they must have the same category so they can be displayed on the same graph. We're looking at September 15th, and they're going to give me the values in a second. So remember, we invested 100, so all three started at 100. So the graph on the stock, it went up to 105. The $100 bond would have declined in value to about 99 because they were pretty even, and the gold investment held its initial value of 100. So on September 15th, your complete portfolio now would be worth the sum of those threes of 304. But remember, we only put in 100 each, so you put in 300. So really, you've gained $4 for investment. All right, graphic conversion. Now, when you have the ones on your homework, I'm going to tell you at the end of the PowerPoint, there's a little icon you're going to want to push to see the graphic. It's like you see the words, but you don't see the chart. There's a little thing that says push this icon. Okay, so here we have multiple bar graphs of the number of U.S. households with computers and the number of online households. So some that just have computers that are not online and the ones that are online with their computers. So this again is measuring, I'm just looking at the label on the chart, PC, personal computer, and online households in the U.S. from 1995 to 2003. My blue bar is the households with the PCs, and the online is how many of those are online. So I can compare here from 1995 through 2003 and look at some trends in both how many people own PCs as well as how many are online. And something else that's interesting to me is look at the proportion. Like in 1995, about a third of the households that owned a computer were online. Then in 1997, that red bar creeps up till it's almost half. 1999, it's well past half of those who have a computer are online. And as you get to 2001, 2003, almost everybody who owns a computer is also online. So that's how you can use a multiple bar graph. All right, now they ask us to redraw it as a multiple line chart and briefly discuss the trends. All right, we talked a little bit about the trend. You can see it. But when we put it into a line, we're just going to put a dot where the top of each of those was. So you can kind of visualize what it's going to look like before I flip here. So there we go. So just envision the bars that were underneath these a minute ago. We put the dots. Still the same information, still over the same years. One is above the other, multiple line. So we just change the two bars to two sets of lines, place a dot in the corresponding place, and then connect the one with the same numbers. All right, so now the trends we can see is that both are increasing, which I talked about when I was just looking at the bar, but we also see a second trend by comparing those bars within each year. So again, the number of online homes was about a third of those with, but as I keep going, a higher and higher percentage of the users were going online. So if we wanted to use this to project trends into the future, which is what statistics a lot of times is about, is to look forward, it seems likely, not definite, but likely, that the number of online households will approach the number of households, and both will approach the total number of households in the United States. So as we go on, basically it looks like the trend is if you own a computer, you will also purchase the online access. All right, let's take a look at stack plots, just what they sound like. Things that are stacked on top of each other. And think of them like wedges. So in a pie graph, you had wedges in a pie that look like a piece of pie. Well, here we're going to have vertical stacks of these. Well, sorry, the actual piece is horizontal, but I'm going to stack them vertically. So let's take a look at what this looks like. They can be stacked in bar charts or line charts, even though at the beginning. Notice we were up here at around 800 for the top of the highest wedge, and notice it's all down closer to 600. So where was I for the downward slope, blah, blah, blah. From nearly 800 deaths per 100,000 in 1900 to 525 in 2003. So the drastic decline in the thickness of the tuberculosis wedge shows this was once a major killer, but it's now pretty well wiped out. So that being gone really made my wedge a lot smaller. Meanwhile, as we mentioned, the cancer has steadily been rising, but has dropped somewhat since then. I think as people have become more aware of the things that can kill you from cancer that you could prevent, such as smoking, obesity, it has been proven those things can lower your cancer rate. All right, another type of graph we can look at shows geographical data. So here we have, you've seen these on the news. The thing is that I have to have a color-coded map here. So the different states, in this case, because of their geographical location, is what we're looking at. So we're just going to color code it. All right, so our label is about state energy use. And my key over here shows the BTUs. I forget exactly what that stands for, but it's how much energy people are using, measured in BTUs. So the dark blue is the highest consumption, and look at that, that's 8K, that's Alaska. All right, 900 to 999 is my light greens. Those are up in the middle of the country north. My light blue, 800 to 899, that's Louisiana down there. Then I have another kind of a greenish one. Oh, Wyoming was dark green. North Dakota is light green. Then I start kind of working my way down to the orange guys, or 300 to 399. I have a whole lot of those. And interesting, you can see that the purple is a lot of the Midwest states there towards the west of the country. All right, so let's take a look at some trends. If I was just looking at this, I'd go, oh, well, those people out, towards California are the most energy conscious, and we kind of know that's true. Plus, there's some of the warmer states, so they don't get as cold as some of the other ones. Not Colorado, but some of the other ones, especially Arizona, California, Nevada. All right. Now, interesting, what shoots my theory is look up in New York, New Hampshire, Maine. That's the same color. So they still have a lower energy, which I find interesting. They must be doing some really heavy conservation kind of things. All right, so what can you learn from the histogram that you cannot learn easily from a geographical display in figure 323? All right, they're going to show them on the next slide. And what can I learn from the display you can't learn from the histogram? Any surprising geographical trends? All right, so this state energy use, we've got it on the histogram as opposed to the geographical map. So when you look at it, it really shows that a large number of states have between 200 to 500. That's the majority of your therms there being used, BTUs. Then over on the frequency table, it kind of shows the same thing, that you have 16, 19, and 10 are somewhere between 200 to 499. So the largest bulk of your annual energy use per person is less than 499 or 500. So that's something I couldn't tell by looking at the geographical data. So sometimes it helps to look at it in multiple ways. All right, now I know you've seen these on the weather map. They got those patterns flying around there. So this is a contour map of the United States at a particular time. Each of the contours are lines. Usually people think of lines as straight, so contours is just a curved line. Connect locations with the same temperature. So for example, my temperature is 50 degrees everywhere along the contour labeled 50. So that's down there in the California, Nevada area, and everywhere along that contour. So it's really hot over there in Florida, down in Mexico. It's really cold in the blue way up in Canada and up the northern states there. All right, so you guys understand how to read that. And when they talk about this on the weather guy, it's always interesting to see how these things flow around. I love the graphics they have on that. All right. Let's see. Note that the greater temperature differences means more tightly spaced contours. So for example, that closely packed contour in the northeast indicate the temperature varies substantially over very small distances. So, oh yeah, look at that. That big yellow dip there. And that's right along the mountains, I'm guessing. Interesting. All right, so these are fun for me to take a look at too. Three-dimensional graphics, on the other hand, I do not find fun. I have a hard time reading everything. I look at this and all it looks to me is like a bunch of mountains, which is not what it is. So when we get to section 3.4, we're going to talk about misleading graphs, and these three-dimensional graphs can be very hard to interpret. So on your section notes, I've put that these three-dimensional graphs are often used to liven up, but they seldom actually provide any additional information that you could have gotten elsewhere, and they're very easy to be misleading. All right, so perceptions can be off, and we'll talk about that more in 3.4. All right, but let's take a look at this thing. There's so much going on. All right, so first I got to read what it is about. It's the sonic mapping traces bird migration. All right, so sensors across the United States counted each occurrence of the nocturnal or at night flight call of the bobolink to trace the fall migration on the night of August 28 through 29, 1993. Computerized the data show the heaviest swaths of birds passing over the eastern part of the state. So I'm looking at this going, all right, let's see. All right, first thing we have to do is take a look at the three axes here, not just two. So notice on the top right it says number of birds. So that scale up that side, the 10, 0, 10, 20, 30, 40, 50, 60, 70 is the number of birds going up that way. All right, along the bottom square, you got to think of this as a box. So the number of birds is up the side of the box. Now on the base of the box you have a length and a width. You've got Cuba, Alfred, Beaver Dams, Ithaca, Richford, I'm probably not saying these right, Oneida, can't read it, and Jefferson. Those are the towns that we're going through, and I can tell that by looking up at the little New York State map that they kind of hung up over there in the top left side. So I can see Cuba is westmost, then we get to Alfred, then we get to Beaver Dam, Ithaca, Richford, Onwanta. Anybody who's from New York can write me an email and tell me how to say that. And Jefferson. All right, so as I'm traveling from west to east, that's the way it's set up along the bottom of that scale on the bottom. The other bottom one is the hours after 8:30 p.m. So I have 8 hours, 7 hours, 6 hours, 5 hours, which are hours after 8:30 p.m. as time is going by. All right, so on the inset map, they talked about the east to west. We talked about that already. As what time of night as they headed south for the winter. So we got our three axes, our number of birds, our time of night, and our east-west location. So you can indeed see that funky looking big brown one there shows that they were passing over, oh, of course, it's the one I can't say, Oneida, Oenta, at peak of about 60 birds at, it looks like, right about 6 hours after 8:30 p.m. So what is that, about 2 something in the morning? All right, now this one here, Olympic women, describing 3 trends shown in figure 3.28. All right, so this map is about the ever-growing presence of women in Summer Olympics. So here we got lots of stuff going on. There's just so much going on. I have to look at my key here. So the little circle with the wedge is the percentage of women participants. The pink line is the total number of women participating. Then I look down along the bottom axis. I see there's no games in 16, no games in 40-44. So the pink is the number of events for women in that year. So 1900, 1904, 08, 12, 16, etc. And those no games were due to wars, by the way. All right, so number of events for women. And then up the side, we have the number of women participating. And then you can see the bar, or sorry, the little circle is pie shaped, which gives you the percent there. Whew. So if we're looking for some trends, describe 3 trends shown. Well, let's see. First off, we can see that the piece of pie wedge is getting bigger. So the percentage of women participants is increasing. As we look at the pink line, the total number of women participating is also going up. So that the percentage is also going up means that the number of men are staying more steady, so that my total number of participants doesn't change that much. So it's the percentage that's changing. So that's different than just saying there's more women participating. If there's also more men, then your percent wouldn't change. But here, more women are participating. Then also notice the number of events for women, which explains a lot of this. We only had 3 events in 1900. Up in the 2004? Yeah, 2004, 135 number of events for women. Wow. So that women participating both percentage-wise and total just skyrocketed because there was more events for women to be. Well, let's see. The number of events for women, I'm not sure how many more there are, but having more and more women participate, I would think, would continue, which would lead my total to also increase. But I don't think it'll increase as exponentially as it did here, simply because the number of events, it's got to tap out at some point. All right. All right, so usually I do a few examples from the back of the book, but since this information is dealing with graphics in the media, it's really hard to do them via PowerPoint. So the ones on my stat lab are pretty good, but what I wanted to show you, when you go to my stat lab, make sure to click on that little icon. So I have a big red arrow pointing towards the icon. This was problem 1. It says click the icon to view the stack plot. If you don't do that, you won't see it. So you're like, where is it? So make sure you click on the icon. A second thing that I show them when I'm in class, they're like, oh, I never saw that. That little magnifying glass. I personally wear reading glasses. You probably don't. But I can't read some of the small print they sometimes have. So if you want to make the graph bigger so you can read the scale, you can read what the titles are on the side and the top, all those labels, make sure to use that magnifying glass. So when you see a chart, you see that little thing there, this red arrow is pointing into it, that's a magnifying glass. You can make it small, medium, or large. All right, I will continue with 3.4, which talks about some of the misleading things you'll be seeing in the graphs, and that'll end up chapter 3 for us. All right, thanks. Bye-bye.